Hello, I'm Neil Foreman and welcome to the Car Builder Solutions DVD. My son Matthew and I have been putting things together for more years than I care to remember. From Cobras to Sevens and cars like this Foreman Can-Am, this Foreman Berlinetta, this Covin 911, and even this prize-winning modified Focus RS, and this Rotaway helicopter.
We're going to share with you some of the tricks and techniques that we use in the workshop. We'll also show you how to get the best out of the products featured in our catalogue. Each time we're using one of these products, this symbol will appear on the screen. We hope you enjoy the film.
Before we start, just a few words on workshop safety. It makes sense to have some basic pieces of safety equipment to hand if you're building a car, like a pair of tough leather gloves, a simple dust mask, and most importantly, a pair of safety glasses. To make a good job of building your car, it's important to be able to measure things accurately, and there are a few tools that will help you do just that. A tape measure, a 6-inch steel rule with imperial and metric markings, a large square, a smaller combination square, and this one has a built-in spirit level and scriber, and an accurate centre punch for marking holes. But the most important piece of measuring equipment you can buy is a measuring caliper, like this vernier one here. When I was an apprentice, one of these cost a week's wages. And this is its modern equivalent, the digital caliper. This has an easy to read display that you can change from imperial to metric at the press of a button. This caliper can measure accurately to 0.005 of an inch or 0.01 of a millimetre. This caliper has 4 measuring functions, and we're going to demonstrate those to you using a pulley. The outside jaws are used for measuring the width of a component. The inside jaws can be used to measure the bore of a component, like the hole through this pulley. This plunger on the end moves in and out as the caliper opens and closes, and you can use this to measure the depth of a slot or a groove. And on the back is a shoulder that also moves as the caliper opens and closes, and you can use this to measure the step in a component. Most kit cars feature aluminium panelling somewhere on the chassis, and we're going to show you how to tackle that job. We've made up this mild steel mock-up of a cockpit corner with triangulation and a seatbelt mounting bracket and another little bracket welded on there. We're going to show you how we would panel this with aluminium. Of course, this frame didn't start like this. Here's how we coated it.
We're going to give the frame a coat of paint using our epoxy chassis paint. There's no need for primer, goes straight on, gives you a durable satin black finish. To avoid heavy build-up, give 3 or 4 light coats and then leave to cure overnight.
The first thing to do with all your aluminium panels is to remove the sharp edges. We use a file. This panel is going to be fixed permanently to the chassis, and we're going to make this one removable. You can see here that the return on the aluminium panel doesn't sit square and flat against this tube because of the weld in the corner. So the first thing we're going to do is notch out both the corners to move the panel flush in the angle. So we mark it at the edge of the tube on both sides. There are several ways to cut aluminium panels. You can use a hacksaw, or you can use snips. These are called gilbows, and what we've got here is a left hand and a right hand gilbow. You can see the difference. One is designed for cutting left hand circles and one right hand circles, but they're very useful for cutting corners. You always need to lay the top blade flat on the work and lift the bottom blade up to it on the waste side, and do the same with this one. If you keep the blade flat on the good side and raise the waste side up, you can nip the corner out without distorting the panel. Just a quick tip, if you've got a vise, it makes sense to make a couple of soft jaws for it. 2 pieces of scrap aluminium, just fold it over, and that way you won't damage anything you put in the vise. There's our piece of aluminium, our saw. And square it off with a file. And this is our panel, and don't forget always to keep the flat blade on the good side and cut with the raised blade on the waste side. Here we go. And in the vise. And again, clean up with a file. Okay, here you can see the panel has been cut away in the corner. It's sitting flat on this tube, clearance for the weld, and it's also sitting flush with the vertical tube, so that when we mount the next panel on, it will sit flat. This is going to be the fixed panel, and we're going to be riveting and bonding this to the top and the bottom rails. First thing we do is stick a bit of masking tape along the edge so that we don't scratch it when we're drilling and marking it. We can then work out the spacing of the rivets either using a tape measure or with another little trick. This is a length of dressmaker's elastic, which you can buy in any haberdashery store, or pinch it from the wife's underwear drawer. Tape a length of it to the bench, like we've done here, not under tension, but just tight enough to stay where it is, and then with a pen, mark every inch. You then have a stretchy tape measure. You need to mark the start and end rivet hole. We'll come in about 1 inch from this end for the first hole, and 1 inch from the other end for the last hole. You can then stretch the elastic until you get the spacing you're after. In this case we're going for about 50 millimeters, and then get an assistant to transfer the marks from the elastic to the masking tape. And that method will work along any length of panel. We want to put the line of rivets in the centre of the tube, and you can see that the panel doesn't come up to the edge of the tube. The panel starts where the radius of the tube finishes. So we want to find the centre of the tube, which is actually about 3/8 of an inch from the edge of the panel. So we can mark 3/8 of an inch at that end, 3/8 of an inch at that end, and join the dots across the marks. Which gives us all our hole centres. Here's another little trick that you can use to mark the hole centres using your digital caliper. You can set your distance away from the edge of the panel on the readout. We'll call it 10 millimeters. Lock it with this little screw, and then you can run the caliper down the edge of the panel, just scratching a very light line on the masking tape. This is the little centre punch we showed you earlier. Very handy tool. Put on the mark, spring loaded, and give it a ding. Right, we're ready to drill the holes for riveting the panel to the frame. First thing to do is to clamp the panel to the frame. We've got a couple of little G clamps, and we've wrapped some masking tape around the bottom so we don't scratch the paint. First we need to drill just a couple of holes in the panel. Battery drill is fine for this, but make sure it's a decent one with a speed over 1000 RPM. We've drilled 2 holes in this panel, one at this end and one near this end. What we're going to do is temporarily fix the panel to the frame with clecos. This is a cleco fastener, and it's operated with a pair of cleco pliers. Now, these are available in 3 sizes. The one we're using here is an 1/8. Here's how it works. The cleco expands as you release the pliers when you put it through the hole. We can now remove the clamps. And the panel's held securely in place, so we can drill all the rest of the holes perfectly accurately. Once you've drilled all the holes, you can then remove the clecos, take off the panel, and deburr all the holes in the panel and the frame. The top edge we're going to dress over the round tube, and to do this we're going to use a hard rubber mallet. We put clecos in all the holes to hold it securely in place. We're just working away along the tube slowly in 2 or 3 runs. to get the aluminium to form neatly around the round tube. Before we finally rivet the fixed panel, there's a few more things to do. One of those is to prepare the removable panel and the frame. We lay the removable panel in place and we've got to make a cutout for this bracket. So we put on the masking tape on the panel, we've marked the width of the cutout, and we now need to mark the depth of the cutout. There are many ways to cut a piece from a sheet of aluminium like this. We're going to use this little pair of nibblers. Very neat. Matthew's going to show you a few other ways.
This is a scroll nibbler. We're going to use it to cut the corner from this aluminium panel. You need to keep constant forward pressure and squeeze the jaws gently. These are aviation snips. We're going to use them to cut the corner from this aluminium panel. One blade flat against the good side of the job. For this cutout, we will use the drill and file method, which is better suited to thicker panels. Drill a series of holes around the edge of the cutout as close together as possible. You can then link up the holes with a hacksaw. And then file to your line on all sides. You should then deburr all sharp edges. The final cutout is a square in the centre of a panel for things like switches. We're going to start by making a hole in the centre with a stepped hole cutter. These are available in both metric and imperial, either singly or in sets. Step drills are the easiest way to cut a neat, clean hole in any sheet material. Although you can use a step cutter in a hand drill, we've chosen to use a pillar drill. You can buy a 5-speed pillar drill like this one for less than 50 quid in your local DIY store or over the internet. It's by far the easiest way to drill a number of holes and get them perfectly accurate. The step drills will cut better with some lubrication, some WD-40 or paraffin, quick squirt on the job, and keep gentle pressure, step through the sizes until you reach the size you need. You can then cut to your marked line with the nibbler. can then tidy your hole and deburr with a file. There we go, no marks, no scratches, no distortion.
Before we carry on panelling our frame, I'd like to talk a little bit about making holes. If you're building a car, then you're going to be making a lot of holes, and it's often very important to get the size accurate. The most common tool for making a hole is a twist drill, and you can buy twist drills in sets like these. This drill set includes 3 different ranges of drill sizes: number drills along here, letter drills and fractions, and this set completes the range with a few metric sizes. Using these 2 sets, you'll be able to find any drill size you want to within a few thousandths of an inch. Another worthwhile investment is a wall chart or one of these little reference books. Inside here you'll find all the drill sizes, tapping sizes and their equivalents.